Okay, in this video, we're going to focus on a different way to anti-differentiate, which is called U-substitution. So we're still going to look at inner functions and outer functions, but this time we're going to be replacing the inner function with the letter U. Okay, this is specifically useful when it is difficult to find that g prime of x, like especially if it's impossible to find g prime of x from g of x. You can always choose U-substitution instead of that pattern recognition. So if you had a tough time with the pattern recognition, try U-substitution, see if you like it better. Okay. Consider this example. So in this example, we have 2x minus 1. That is the inner function, right? 2x minus 1. The derivative of 2x minus 1 is just a 2. 2 is not part of the integrand. No. And is g prime of x attainable, gettable, possibly findable, by multiplying the integrand by a constant? Okay, so integrand is the whole inside in between the integral symbol and the dx. So all this junk is the integrand. If we just multiply times 2, yeah, then we would have a 2. But what is this x doing? It's just kind of hanging out here. So if the whole outside bit is not whatever g prime of x is, there's like an extra x or there's not enough x's, we have a problem. So no, in this case, we can't just transform an x into a 2. It's a problem. So we use U-substitution instead. So you will definitely have to learn this method because some problems need it. Okay, so first off, let's let U equal the inner function, which is g of x. So U equals 2x minus 1. This is all side work, all of this stuff so far. Okay, the next thing we're going to do is find du. So we're going to take the derivative of both sides with respect to x. So it's going to be like u equals, I'm going to leave some room, 2x minus 1. We're going to take the derivative of both sides with respect to x. Right? That takes the derivative of u with respect to x. This takes the derivative of 2x minus 1 with respect to x. The left side, we're going to write that as du dx. Just like when we did related rates and we had like dr dt, right? Same kind of deal. The right side, though, since this is the letter x and this is the letter x, we can actually take that derivative. The derivative of 2x is 2. The derivative of negative 1 is 0, so it goes away. Okay. We are now going to solve to get dx by itself. What that means is we're going to kind of treat this like a fraction. We know it's not a fraction, but we treat it like a fraction. This says divide by dx, so we're going to multiply both sides by dx. This is a very common thing. We're going to do it like every time. So du equals 2 times dx. But we're not just solving to get du by itself, we're solving to get dx by itself. So we need to divide by this 2, or multiply both sides by a half. That'll show up nicer because we don't want du to be in a fraction. So we're going to multiply by a half. 1/2 du equals dx. Cool. I'll show you a little shortcut as we get to future problems so it doesn't take this many steps, but this will always work every single time. Okay, next thing, find an expression for x in terms of u. Because we have this extra x that's hanging out here. Our goal is to rewrite this whole function, this whole integral, with u's and numbers instead of with x's and numbers. That's our job. Rewrite this. Currently, we can rewrite the 2x minus 1 as u. We got that here. 2x minus 1 is u. And we can rewrite dx as 1/2 du. But we have that other x that's just hanging around that we don't know what to do with. So if there's an extra x, we got to do this other step too. Find an expression for x in terms of u. So I'm going to take my little u equals equation. You do not want to start using this one. Not at all. Use this guy. U equals 2x minus 1. We have to solve for x because we're trying to substitute out an x. We'll add 1 to both sides. U plus 1 equals 2x. And then divide by 2. You can either divide both of these things by 2 or the whole thing. It doesn't really matter. U plus 1 over 2 equals just x. Cool. So once all three of those things are done, we're going to rewrite the original problem using those 3 bits. So this integral of x times 2x minus 1 cubed dx gets completely rewritten. The integral stays. X is the same thing as u plus 1 over 2. 2x minus 1 is the same thing as u cubed. And then dx is 1/2 du. Awesome. You always, every single time, want the dx or the du or whatever it is to be at the end. Every single time. Okay, we can do a little bit of rewriting, like the 1/2 and this divided by 2 can move out front. 1/2 times 1/2 is 1/4. So 1/4 times the integral of u plus 1 times u cubed du. So this guy and this guy moved out front as a 1/4. And now our job is to just pretend that this was the original problem for most of the rest of the work. So pretend that this was given to us. Okay, this does not quite look like a polynomial yet. It looks like we should use a product rule, but there's no product rule for integrals. So let's see about distributing this u cubed. So this is 1/4 times the integral of u to the 4th plus u cubed du. Okay. Hey, look at that. Those look like happy little polynomials. So this will be 1/4 times the integral of u to the 4th is u to the 5th with a 1/5 in front plus u to the 3 goes up to a 4 times 1/4 du. No, not du, Miss Campbell. No, we just took the integral, so the integral symbol and the du go away. There, it was totally a test. Yep. Okay, let's distribute the 1/4 so it's not just hanging out there in the front. 1/4 times 1/5 is 1 over 20. U to the 5th plus 1/4 times 1/4 is a 16th. U to the 4th. No du's at the end. We did forget something though, or who forgot it? Me, I forgot it, plus c. It does not matter if the plus c gets multiplied by the 1/4 or not, because c is a constant and 1/4 of c is a constant. We don't know what it is. Even if you were trying to solve to get like regular old f of x or whatever, trying to actually figure out what that constant was, it wouldn't matter in the grand scheme of things if you had multiplied by the 1/4 or not. Okay, the last thing is that our problem started out with x's, and our answer currently has u's in it. That's a problem. So we're going to go back all the way up to here on number 1, where it says u equals 2x minus 1, and everywhere we see a u, we have to replace it. This is 1/20th times 2x minus 1 to the 5th plus 1/16th times 2x minus 1 to the 4th plus c. Yay, it's our favorite. Okay. If you want, at some point, you can go back and try U-substitution on the problems on the previous couple of pages. 1, you know what the answer is supposed to be. 2, in those problems, you know that they're going to work out pretty nice. There's no extra x's, so you won't end up having to do step 3 at all. You'll just have to do steps 1 and 2. So if you want to pause and try one of those and see if it works, awesome. If not, I do not blame you. This is kind of a long process. Okay, we're gonna do this next one. We have a square root inside of a fraction, kind of not pretty. We need to figure out though, what is the inside function and what is the outside function? Inside function, outside function. Well, we got a square root with stuff inside, so the x plus 4 is probably our inside function. Okay. If you try something, if you're not sure, just try something. Be like x plus 4 equals u, or 2x plus 1 equals u. Try it. Set the thing equal to u and see what happens. Okay, so I'm going to start by rewriting this guy as the integral of 2x plus 1 times x plus 4 to the negative 1/2 dx. Right? That all looks good. Parentheses across the top, bottom goes in parentheses to the negative 1/2 power. Since the x plus 4 is the most complicated bit, is probably going to be u. That's probably your best bet. Okay, u equals x plus 4. Sweet. So that's this bit. That's going to be a u. What else needs to go away? The dx needs to go away. So let's find du. If u equals x plus 4, then we're going to take the derivative of both sides. So this one will become dx of u, this side dx of x plus 4. So du dx equals 1, right? Derivative of x is 1, derivative of 4 is nothing, so it's literally just a 1. This one, since you're doing the thing, the ddx part goes away, right? It gets used to do the process. This one, you can't actually take the derivative of u with respect to x. So there's like nothing you can do. It's stuck there. Okay. We want dx by itself, so we will multiply both sides by dx. That gets us du equals 1 times dx is just dx. So in this case, du and dx are interchangeable. Cool. So we can get rid of the x plus 4, and we can get rid of the dx in our original problem. That's this and this. So we still have this 2x plus 1 that we need to get rid of. So we're going to take something that doesn't have dx's or du's. We're going to take this little guy and solve it to get x by itself, so we can substitute away something instead of the x. Okay, u equals x plus 4. Solve that, and we get u minus 4 equals x. Now you might notice that this was not just an x this time, it was a 2x plus 1. So I'm going to even go a little bit further, and I'm going to say 2x plus 1. We're going to substitute in the u minus 4 right here. So 2 times u minus 4 plus 1. We're doing the work off to the side, so we don't have to do it while it has the integral. Distribute 2u minus 8 plus 1 is the same thing as 2u minus 7. So this 2x plus 1 that we started with in the problem gets replaced by 2u minus 7. All right, we have a place for everything, right? 2x plus 1 gets replaced with this, x plus 4 gets replaced with u, dx gets replaced with du. We get to substitute everything away. This is perfect. So this is, instead of 2x plus 1, we're doing 2u minus 7 times u to the negative 1/2 du. Now you might be thinking, that still looks super complicated. Why is this any better? And here's the reason. Since there's only one term that has that exponent on it, you can distribute this to both of these terms. You could not do that when you had the x and the 4. I mean, I guess you could, but it wouldn't be useful because you couldn't simplify it further. Like this could multiply times the 2x and this could multiply times the 1, but it's still not like pretty. Okay, it's hard to take that integral. So let's distribute. U to the negative 1/2 times 2u is 2u to the positive 1/2, right? 1 minus 1/2 is positive 1/2. Minus 7u to the negative 1/2, since it's two terms now, parentheses, du. Okay, so we substituted to get to here, and then from here to here was distribute the single term, which was u to the negative 1/2. Don't change it back to x's until after you've taken the integral. That was the whole point, was to rewrite it so that this is a lot easier to take the integral. So the integral, u to the 1/2 becomes u to the 3/2. And then we're going to take the 2 and multiply it times this reciprocal, which is 2/3. Over here, u to the negative 1/2 increases to positive 1/2. And then the negative 7 gets multiplied times the reciprocal of this, which is 2. And we'll go ahead and put that plus c that I'm not going to forget this time. And simplify some stuff out. So this is 2/3 times 2 is 4/3. U to the 3/2. Notice I said u, but I really put parentheses. Minus 7 times 2 is 14. U to the 1/2 plus c. We want x's at the end, so we're going to go way back up here to u equals x plus 4, and we'll replace u with x plus 4. And there it is. That's our answer. If you really want to change it to square roots, go for it, but there's not a lot of point. Okay. You are welcome to stop here, but I am going to take one of those problems from that previous page, like I kind of suggested, and work one of them out using U-Substitution, so you can see that you can use this process for any of them. I'm going to pick this one because it's not very pretty. Especially because like we had to come up with a number to go in there, right? The 3x, we didn't have the 2 that we needed. I'm going to break this up into the same organization. One, 2, 3, and 4. And our original problem is the integral of 3x times the square root of x squared plus 2 dx. Okay. We usually like to rewrite those with 1/2 exponents, and we will do that. Cool. So u is going to be this inside function, which is x squared plus 2. Ooh, I also want to show you that easier way of writing your derivatives, like the du and the dx and all that. So if we take the derivative of both sides, the left side, if you put du, and then you take the derivative of the right-hand side, the derivative of x squared plus 2 is 2x. If you put times dx over here, that takes care of the dx that would be over here and moves it to the right. If there's supposed to be two terms, you got to put them in parentheses and then the dx after it. Okay, next job. We want to get dx by itself, so let's get rid of that 2x by dividing, or by moving this over to the left using division. So it'd be like 1 over 2x times du equals dx. Okay, if you liked it the other way, it's like d dx of u equals d dx of x squared plus 2, or you can just take that derivative. All right, cool. So dx is by itself. So that's going to take care of this bit. It's going to take care of this bit. So we still have a 3x that we need to get rid of, right? Wrong. Take a look. There's an x here. So I'm going to skip step 3 and we'll simplify out and see what happens. So this is going to equal the integral of, we had a 3x. I'm going to rewrite it there. Okay, we had our parentheses to the 1/2 power, and that's now going to be a u, right? Because x squared plus 2 is u. And then dx, that's a weird bit. dx is 1 over 2x times du. 1 over 2x times du. All right, so I put this piece here and this piece here. And we'll do some simplifying. This x and this x will cancel each other out. So we're left with the integral of 3 over 2 times u to the 1/2 du. Okay, so we didn't end up having to solve for x because there wasn't an extra x hanging out after we solved for the dx, because that little over x took care of it during the simplify step. Okay, let's take an integral. This will be u to the 3/2 power, and then that 3/2 that's hanging out here, we're going to multiply times 2/3. Bring a little plus c down. These guys cross cancel. We're left with u to the 3/2 plus c. But we know we can't leave u in our final answer, so it's something to the 3/2 plus c, and that something is x squared plus 2. And this is exactly what we got on this problem. Okay, this method definitely took less work, but I would recommend practicing some of those U-substitution, like the U-substitution method, when you don't have to find the x. So especially on these problems, just to get the hang of it. Okay. All right. If you find on those problems as you're trying U-substitution that you still have an x over here that you weren't able to cancel out, then you do have to set this like equal to x, like find what x would equal and then substitute it out. That's it, guys. Have an awesome day.